In this video, I want to teach you how to solve Hess Law problem. Display on the board here. These are stuff. Now, these are questions you will regularly see in the exam when it comes to what thermodynamics. Hess Law is one big part of thermodynamics topic you must understand very well. So in this video here, I'm going to show you simple steps in what solving this type of problem here. In this video, I'm going to solve three major problems. After the end of this video here, you should be able to understand everything about what Hess Law. So after everything, you should be able to understand everything about what Hess Law calculation. So you're going to have to stick to the end of this video and take down every single thing. Make sure you follow the step I'm going to give to you in this video. By the end of this video here, I'm going to link a link to a complete PDF on this one here, so you can check it out, download it out, use it for your personal study. So let's get into it. Now, the first thing you want to do here when solving this problem here, you are combining these three equations to get this particular reaction. Do you get that? So they're asking you determine what the delta H, which was the enthalpy for this reaction. So what you want to do here, you are combining everything here. The first you want to do here is the first you want to do is circle out species that are unique to a specific reaction. In the sense that what is here you cannot find there, you cannot find there. That is what is here that is only you can only find there is not here, it's not here. So that we call unique species. So if you check it very well, here we have oxygen, here we have oxygen, here we have oxygen, here we have CO2, here we have CO2, here we have CO2, here we have water, here we have water, here we have water. So it is not what, now these ones are not unique. But if you checkmate this one here, C3H8, you can only see it in the first reaction, you cannot see the second, you cannot see it in third. So what you want to do here is circle out this guy. Just circle out this guy. The next one here is C3H8. C3H8 is only found in the second reaction, so we circle it out. Just why H2, which is hydrogen, you circle it out. So that's the first you want to do here. If you can identify compounds that are unique to a particular reaction, then you are on your way towards solving Hess Law problem. Do you understand? So the next you want to do here is compare each of these given equation to the main equation here, and make sure you make appropriate adjustments. Now, remember I have circled out each of the stuff here, right? So if I'm comparing each of them, my eye should point towards what I've circled out, and make sure that what is here corresponds here. That is, what I circled out here should correspond to the in this main equation here, and they should be on the same side. Okay? So if you look at C3H8 is on the reactant side, C3H8 is on the product side. They are not on the same side. So I'm going to adjust from here. I'll make sure that this one should move to the product side. So if I should reverse it here, that is, the whole of this one here will move to this other one here, and the whole of this one will move to this other one here to ensure that these two are on the same side. Because here is on the product side. This guy should be on the product side. So if I should do that here, the whole of the products here move to the reactant, and all of the reactant here move to the product. Now the only thing that changes here is the positive sign. Now I want to reverse this sign here. Do you get that? So yeah, if I should reverse the first equation here, I have 3CO2 plus 4H2O, giving you here we have C3H8 plus 5O2. Just that. So my delta H here is now, because I reversed it here, minus will change to plus, or negative change to positive. So it's going to be plus 2220. Now, the unit of enthalpy is kilojoules per mole. So by the end of everything here, you must include that kilojoule per mole. Now, here, we are done with the first one here. Let's look at the second one. In the second one, C3H4 is on the reactant side here, which corresponds to this guy. Just like it corresponds to this one here. So since they're on the same side and the same mole, no problem. So this guy is also the same to this guy here. So we just have to write like that. So it's going to be C3H4 plus 4O2, right? Giving you 3CO2 plus 2H2O. Can you see that? So C3H4, so you don't have to write like that. My delta H here, remember I didn't do any adjustments, so or any changes, so you go to remain the same minus 1937. Can you see that? 1937. The next is what is hydrogen. So here we have two. Here we have two. So they're on the same side here, right? So you just have to write like that. 2H2 plus what? O2, giving you what? 2H2O. This is that. So we have made what the appropriate word adjustment now. But you can do this one right. You can even combine them together and cancel out species that are common multiple times. If the checkmate is very well, let's combine them together. So my delta H here is what? Sorry, my delta H here is what? Minus 571.6. Remember, we have is the unit is what kilojoules per mole. So now let's combine them together. If you find that here we have CO2, carbon dioxide, here we have carbon dioxide. They are what on the opposite side and they have the same mole, right? So this guy will cancel out this one here. Just that because two are on the same, they have the same mole and the opposite side. So when one species occur multiple times, what we want to do here, so figure out if they're on the same side or on the opposite side. If they're on the same side, you add them together. If they're on the opposite side, you subtract them. Do you get that? So this guy will cancel out this guy here. The next one I can cancel out is water. So here we have 4 on the what? Reactant side. But here we have 2 molecules of water here, 2 molecules of water here. When we sum them together, remember 2 of them on the what? Product side. So 2 plus 2 is what? Is 4. So this guy and this guy will combine together to cancel out this one here. So 2 plus 2 is what? 4, which will cancel out this guy here. So you cancel out. The next is what? Here we have 5 oxygen here, right? So the next you want to do, make sure you what? You add them together, 4 plus 1, which is what? 5. So these two, we cancel out this one here. Nothing else can cancel it out. So let's look at what the products, the reactant side. In the reactant side, here we have C3H4 plus 2H2, giving you what? C3H8. Now, my delta H, what will happen here? The way it is here, plus this, minus this, minus this. Punch like that in your calculator. Do you get that? So you're going to be plus this, minus this, minus this. It's going to give you what? Your minus 288.6. Now, the unit is what? Kilojoules per what? Per mole. That is the what? That is the unit. So you can see how easy it is. You get that? So let's look at another one here. If this video is helpful, please leave at the comment section. This video is helpful. I'm getting tons of value for it. If you have anyone that will be of that this video will be of help for, or he or she's having issues with what thermodynamics, please kindly recommend the person to what to Ken Chris. Do you get that? So leave your comment in the comment section that this video is helpful and you're following. That will boost me to what create more content for you. Let me move to the second question. Okay, now let's look at the second question. You can go ahead, pause the video, and try it for yourself and see if you are going to get the answer following what I've done in the first example. So you can go ahead, pause the video, and try it. So now let's do it together. Now there's something I didn't tell you in the first question, which is very, very important. When the question is being given to you like this, therefore you have to analyze the question and check if the reaction is balanced. Because if, for example, now this reaction is not balanced, what happen here? No matter what you do, you're not going to get the final product, and which make you struggle because at times the lecturer might make a mistake or might omit something here. So you have to figure it out yourself. So you have to check if the reaction is balanced. So if you look at this one here, this reaction is balanced. This guy is what is balanced, and this is what is balanced. So this is the first you want to take note of. Do you get that? Now, as I was solving the first question, when I was solving at first, before I recorded that video here. Now, I found that when I was solving, as I was explaining, I found that the equation was not balanced and gave it tough time. So I have to wipe it out and I tried producing the video from the beginning. Do you get that? So which is actually a stress. Imagine if you're in an exam condition, it means that you have failed that question already. So that's why you must checkmate if the reaction is balanced. I don't want you to make mistake in the exam. So the question is balanced. When the question is balanced, then we are good to go. Now, several species that are unique to a particular reaction. By now, you should understand what is called several species that are unique to a particular reaction. What is here that I cannot find here, cannot find here. Do that. So here, calcium carbonate is unique. Do that. And CO2 is unique also. So, but if for example now we have 2 of them in a single reaction, you can just circle out one. Do that. You don't need to circle all of them. So you can either circle this one or this one here. Do you get that? So I would prefer for you to circle this one, but let it be like that. So the second one is that Now let's look at what second one. So here we cannot second this one here because this one is here, this one is here. So we can either second out this guy or this one. This that. Then here are what H2. Do you see that? So several species that are what unique to a particular what reaction. Where is it? The second rule is that compare each of the what of the reaction to the what to the main equation. Do you get that? So if you compare this guy and this one here, see calcium carbonate is on the reactant side here, but here is on the product side, right? So what we want to do here is to reverse what the equation. So if you should reverse the equation here, the one of this will move here, the one of this will move here, right? The sign will change what to negative. So that's what we want to do here. So here we have CaO plus CO2. Here we have CaCO3. Do you see that? So my delta H is what? Minus 178 kilojoules per watt per mole. The unit is only what? Kilojoules per watt per mole. The unit will be given to you. Now, the second one, what we want to do here, we want to revise on here because this two is on the product side here, but here they are on the right hand side. So you have to second out this one here. So you have to want to reverse it. So if you reverse it here we have Ca2 plus 2O minus, giving you what? CaOH2. Delta H is what? Minus 16.2 kilojoules per mole. You have to be taking of this here. Then this one here, water. Water is on the right hand side here, but it's on the product side here. So you have to revise one here. Move to here, then move to the other side here. So you have CaOH2, right? Giving you CaO plus what? H2O. Delta H, what will happen here? So sorry, we have to put positive sign here. This is that I will put positive sign here. Very important. Please don't make this mistake in the exam, right? Here we have minus 60.2. Here it's supposed to be a plus because you reverse it, right? Then this other one here, since we have revised one here we have to come plus 65.3. Can you see that? So we are done with what? With the adjustment. We are done what? With the adjustment. The next thing you want to do here now is to combine them. When you're combining them, you find that this guy cancels this guy here, right? And what again? No, that one again. So this one cancel this one. You see that? Which other one again? No one can cancel. So this guy will cancel this one because it can come multiple times. This one will cancel this one because it will come multiple times. So now let's combine them together. So here we have Ca2 plus 2OH what minus, right? Then plus what? CO2. The next one is here we have what? CaCO3 plus what? H2O. Do you see that? Now if you do your work accurately and follow the step I'm doing this video here, you should be able to get the final one. If, for example, now after doing everything here and it does not correspond to this final one here, it means that it is what you wrong. So what now my what data what H? My data H is very easy here. Going to be minus 178 plus 16.2 plus 65.3. So that you get your final answer. Minus 96.5 kilojoules per mole. This is that you can see as it is. If you are following this video here, say you are following this video here and you understand this video, please leave it at the comment section. It's very, very important. If this video is helpful, please always leave it at the comment section that this video is helpful and you are getting tons of value from there. It goes a long way to tell me that you are actually following this video. So let's look at the next one. The next one will actually what the next one is a little bit complex than the first we have done. So please pay close attention. Okay, now this one is a little bit tricky, so we really want to pay close attention. So now remember I told you that the first thing you want to do here is to checkmate if the reactions are balanced, because if the reactions are not balanced, then what you are doing, you are just only wasting your time. So therefore checkmate and which they are what balanced. Yeah, the first one is balanced. The second one is what is balanced. The third one is what balanced. Do you get that? So we are combining them to get this one here. So now what is the first step? What is the first step again? Comment at the comment section. What is the first step in writing or in calculating Hess Law? Leave it at the comment section. What is the first step? right? The first step is what circular species that are what unique to what a particular what reaction. So pause the video and circle out all the species that are unique to a particular reaction. So pause it because I want you guys to what to flow with me. Do you guys? I'm teaching so I will follow up. Now, if you check me very well, yeah, I'm going to circle out what hydrogen, right? Because hydrogen is here, hydrogen is not here. Okay, we are going to leave out hydrogen. Hydrogen is not common. Hydrogen is common, so hydrogen is the hydrogen, so we leave it. What about oxygen? We leave oxygen. What about water? We leave water. So now no species are unique here, so we leave this one alone. Do you understand? We leave this guy alone because H2 is here, H is here, O2 is here, O2 is here, water is here, water is here. Do you understand? So in the first reaction here, no species is what is common. Do you understand? Now look at the second one here. The second one here is what is this guy. This guy is unique, and this guy is what is unique. These two are unique. Do you understand? So we are going to work with these two things here. Leave this one here. This one will now come last. Do you get that? If I can this one here, I'm going to manipulate this one to ensure that I get this as the final product. Do you understand? So whenever you are solving a problem and there's no unique species, you have to leave it alone. Do you get that? Then work with this other one here. Then later with this one here and manipulate it. That's for it to what get this other one to reaction. Do you get that? The goal is to what get this what reaction. Do you understand? So let's work with this one here. Now here we have four here, right? They're on the same side. H2, HCl, HCl, they're on the same side, right? Reactant and reactant. The only problem here is that here we have four, here we have two. So I must make this four to be two. Do you understand? So what am I going to do? I will divide by two or multiply it by half. Remember, if I divide 4 by 2, I want to get what? 2. Is okay? And if I multiply by half, half times 4 is going to be what? 2, because 2 goes to 2, right? So I multiply 2 by half. If I should multiply 2 by half, that is the only change I want to do here. I multiply 2 by what? Half. So if I should multiply it by half, here going to be what? 4 times half, right? And here I'm going to have what? 2. So then I'm going to be what? 2HCl plus half times 1. Remember there's 1 here, right? Half times 1 going to be what? Half O2. Can you see that? Then half times 2, half times 2 is what is 1. So you have H2O. Now, what will that be what my okay? So half times this here is just Cl2, right? Now, then half times 2 minus 202.4. Here I have what? 101.2, right? So my letter H here now going to minus 101.2. Remember, this is that. So that is the reason why I say she pay attention because it's a little bit tricky. Now, this is now what my data what H. Remember, I did change to what negative here because it didn't reverse. We only multiply it by what? By half. You can see that this guy now corresponds to what to this guy here, right? Now let's look at this other one here. Here we have the on the same side. Here we have fluorine, right? They're on the same side, but here we have half. Here we have what 2. So what am I going to do here? I will multiply here 2 by what 2 because here we have 2 times 1 by 2. 2 cancels out 2, right? To ensure that I have 1 at this point here. So what I'm going to do here now, I will multiply here by 2. If I should multiply by 2, half times 2 is what is 1. So it's going to be H2 plus here going to be what F what 2, right? There we have what HF, right? Then remember I multiply by 2, right? Minus. So I multiply by what 2. So 2 times minus 600. Here we have minus 1200. Do you see that? So remember, I've not used this guy here, right? Now, if I should bring this guy in, here we have, follow me close here. If I should bring this guy in, I want to bring this guy in now. Here we have H2 plus half O2 give us H2O. Look at something here. Remember, I have to manipulate this guy because I'm combining all of them, right? Now, if you checkmate very well, because now let me pick one of this guy. It's okay, water. Now let me pick hydrogen here. Just that. this what is the main reaction here, because at this circular end here, these two are very easy for me to find out and compare it to that one here. But at this circular one here, so this one here, I must manipulate in such a way that they will cancel out. When I combine it together, it's going to correspond to that one here. So the thing I'm going to do here is that now here we have H2 and what? H2. Now let's focus on this one here. Now H2, they're on the same side, right? Both are on the same side. So what I'm going to do here, I'm going to reverse this one, the second what reaction. If I should reverse the second reaction, because there's no way I'll be able to combine like this. So the second reaction, the first reaction here, I'm going to reverse it. Do you see that? If I reverse it, do what will happen here? If I should reverse it, I'm reversing what first reaction. So it will be H2O. Then you have what? H2 plus what? Half O2. Delta H now with what? Plus 285 what? 8. Can you see that? Do you know the reason why? So that H2 cancel out H2, right? Water cancel out water, right? This guy cancel out this one here. Do you see that? But if I should leave it like this, there's no way going to cancel. So I'm reversing this one down one here. Remember, I must manipulate such a way that they will cancel out each other to do what final reaction. So if I should combine everything here, I want to have what 2HCl, right? Plus what F2 plus what? Okay, plus nothing. Yeah, we have what? Okay, let me multiply by 2, right? Sorry. Let me multiply by 2, so there's supposed to be 2 here. So it's a mistake. So multiply by 2. So it's going to be 2HF, right? Then my letter H now, somewhere here. So it's going to be minus 101.2 minus 1200 plus 285.8, right? So that would be what the answer. So you have minus 1015.4 kilojoules per watt per mole. So this is what final what reaction. This that. So you can see how easy the goal here is what help you to understand chemistry faster and what better. Please always share this video. The goal here is what for me to monetize this channel so I can what to get receiving a reward for my stress I'm passing through. My passion here is what to help you understand this chemistry faster, easier, so that you're able to what to understand. Very soon I will launch my own personal app where you can go to the app and you can learn chemistry. Once that app is done, so it's going to what make it easier for you. From there you can read books. From there you can watch video on what like on in orderly what manner. Because if you go to my channel here, probably you'll be looking for all the videos, be scrolling through all the videos. Like, but once that app is ready, now you can either go to the app, search for the topic you are doing or the course you are doing, do that, then follow them in orderly what manner. That will be of help to you. Just please always support the channel, and the only way you can support the channel is by you liking and subscribing and commenting. That is the only way you can support the channel for now, and I really appreciate that. If this video is helpful, please give a like and share with your friends. See you in the next video.